Yeah, great. That last presentation is really good about communicating hazard, because there's been a standard way of keeping track of this, and it's been building up in these databases or archives, and it's given me a chance to ask questions like this. So I'm going to take you through how I did that. So with the upcoming season, we're all here excited about the upcoming winter. And I mean, every time we hear it's going to be an El Nino season, you think, okay, warm, it's going to be raining a lot, so it kind of sucks. Yeah, so we get the warmer temperatures up in the Pacific Northwest, whereas with La Nina, we have a lot better association when we hear that in the news. Definitely better skiing around here. With the wetter, more precipitation, more snow, it's colder. So like I was saying, I want to see how this affects avalanche hazard and not just the ski conditions generally. So this is a screenshot of the public bulletin that's produced by Avalanche Canada and Parks Canada. It's the 3 elevation bands, same thing you use here, and then gives more information about what avalanche problems are in the bulletin for the day. Where it is, what elevation band aspect, chances of avalanche or likelihood, and the expected size. So your NWAC bulletin has the same information, what avalanche problem is there, the likelihood and the size. So it's the same framework. Oops. So I was able to access 21 different forecast regions from the 2010 to 2017 season, and that in total, that's over 13,000 bulletins to look at and look for patterns of avalanche hazard. So I was focusing on not just what avalanche problem is occurring in each bulletin, but also the nature of the hazard. So focusing on the likelihood and the size. So here there's a wind slab, and its likelihood, it's with likely size is small to large, whereas the persistent slab, lower likelihood and a larger size. So a way of visualizing this is in the avalanche hazard chart. So on the y-axis, you see the unlikely up to absolute or almost certain, and the size from 1 to 5. The green rectangle is showing wind slabs, so smaller size, but a higher likelihood than the red rectangle, which is showing the persistent slab problem. So, like I was saying, it's quite a big data set with over 13,000 bulletins. So I wanted to look at the different patterns, because we have 8 or 9 different avalanche problems, and they can kind of show up on any given day anywhere in this hazard chart. So to do that, I used a machine learning technique called self-organizing maps to identify the different patterns of avalanche hazard. And I'm calling these typical hazard situations. And I identified 13 different hazard situations. Here is a deep persistent slab situation. So the darker maroon rectangle is showing, on average, where that persistent slab is located on the hazard chart. So larger size than the green rectangle, or square here, which is the wind slab, higher likelihood. And just another example being a loose, wet, and persistent slab situation. So the red here again is showing the persistent slab problem with a larger size. And the blue rectangle is a loose, wet problem. So this could be a situation, say, you get warmer temperatures, or Pineapple Express atmospheric river event. You're getting the loose, wet problem on the surface and maybe waking up some of the deeper layers. Sorry. So I've identified these patterns, and for one season, you just add up the percentage of each hazard situation, and this is getting at this numerical measure of avalanche hazard. Excuse me. And so I wanted to get, like, I should back up a bit. I want to get this measure of avalanche hazard so I can compare it to the ENSO forecast. But just for simplicity's sake here, I'll put those 13 situations just into 5 general patterns. So there's a low hazard pattern, storm, storm with persistent slab, just persistent slab problems on their own, and then warm conditions. So now going back to the ENSO index, or the El Niño-Southern Oscillation index, I'm looking at the average index over the season, so from November to March. And so in the study period, I'm showing here, in the red dots are El Nino seasons, the blue dots in 2011, 2012, La Nina seasons, and then 3 ENSO neutral seasons. So calculate the hazard situation prevalence for each of those seasons. And just to point out some patterns that just kind of jump out is the yellow slice of the pie is for the warm conditions. So maybe not, maybe you kind of have to use your imagination to see it, but more warm conditions in the El Nino seasons. But also too, if you look at it a bit longer and focus on the 3 neutral or green seasons, there's quite a bit of variability. So in the neutral seasons, and this is a season average, so I'll just focus on some of the stronger signals that came out when I correlated the avalanche hazard to the climate index values. So for spring-like situation, so this was something that was often having a loose wet problem and sometimes a wet slab problem. I'm showing here, if it's the darker it is in red, the stronger that signal was related to, like it's more likely to be seen. I'm seeing more of them in El Nino seasons, and see in a bit, but when it's blue, it's more commonly seen in La Nina seasons, or the like colder phase of ENSO. So yeah, this is coming out quite strong in our south coast regions and the Rockies, and lower in the interior mountains. Another warm condition, but like regionally, like this signal's quite strong just in the interior mountains for that loose, wet, and persistent slab situation. So I mean, those aren't a surprise. We know we get warmer weather in these El Nino seasons. So, and then also the opposite's true, less of them in La Nina seasons. Another situation to look at, a deep persistent slab situation. So in La Nina season, seeing more of these in the regions here in blue, so like the south coast and the lower regions, more southern, like saying southern, from, but around closer to the border in the interior mountains, Columbia Mountains. So going to look ahead for this upcoming season, this is the forecasted probability for the ENSO, so what we can expect. And so on the Y, we have the probability of what phase it'll be for that month, and the month is an average of 3 months, so that's why the bottom might be a bit confusing, but it goes like October, November, December through into the spring. So just highlighting here where the winter months are from November to March, and the blue is La Nina and green's neutral. So this is like 60-ish% probability of a La Nina season, La Nina winter. So talked about what signals I was seeing looking through the data for the different seasons. So now we'll go back to the map and talk about what could this winter look like as far as avalanche hazard goes. So maybe most relevant for here in the Pacific Northwest, just the signals weren't as strong or weren't as easy to pull out, but like less storm slabs. What does that mean more of? I'm not quite sure, but if we go into the interior, more persistent slab. So I didn't mention this earlier, but there's a bunch of different persistent slab situations, and so just picking out a few of those. These are the ones that had a stronger signal. It's also kind of interesting to show the spatial differences. So like I'm saying that there'll be less storm slabs in the south coast or Pacific Northwest, but you go further up the coast and maybe more storm slab situations. Same thing with the storm and persistent slab situations. Possibly less in the interior ranges, but in the southern Rockies, which is, I guess, your northern Rockies, possibly more of them. And throughout, less warm conditions. So, I mean, that's, as far as ski quality goes, that sounds good to me. So just to recap, I was looking at the data I was looking at was coming from the public Avalanche Bulletins. I sifted through them looking for patterns in there, and throughout the presentation I was referring to those patterns as the typical hazard situations. Talked about some of the effects that ENSO has on Avalanche Hazard, and maybe made a bit of a loose prediction on this upcoming season. And just want to point out some of the limitations here. It's only eight seasons, so this work will only get stronger as time goes on. There's not really much I can do about that. But what a promising thing is, it wasn't just like one phase of ENSO I was looking at. It kind of had a spread, so I mean, I'll back it up with my word. Yeah, definitely want to thank the supporters of the program, especially Avalanche Canada, Parks Canada, where the bulletins are coming from. It was a good 2.5 years at the research program in Vancouver. And I'll take some questions. Thanks for the time.
Does anyone have any questions for Bret? There's one.
Can you comment? It sounds like you used averages rather than frequency of high hazard situations. Do you think you would have found anything different looking at how common high hazard situations are in El Nino or La Nina years, or do you think it's pretty much similar?
Yeah, you're right. I did use averages. There was definitely a discussion that came up, or it's still an ongoing discussion, but it's a matter of like, with 8 seasons, and then I'm only gonna have 2 with La Nina, 3 with the other 2 phases. So it's kind of just the intention here was just like, we have this data, it's stored in a really nice way, it's a really nice clean data set. So the analysis part wasn't. Yeah, we skimped on that part of it, but it's setting up for a more thorough look into this in the future when we get those extra years.